Okay, welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. And we are still building unassemblize tool. Of course, it takes a lot of time. If you think building things is easy, fast, quick, 1 hour here, 1 hour there, and everything is done, no, it does not work like this. You have to work days on days and days and days and months and years and decades to get the things done. Yeah, we are just at the beginning of the journey. Okay, so we have added in the previous video, we have added a lookup function in the PDB reader to find functions by symbol names. So I think what we can do now is disassemble functions. Build function source line. Instead of giving it a span function, how about we give it a span named function? Because then we can create like chunks of named function. With this, we couldn't do this. We would always need to assemble a container from named functions. So let's make the span named function. Named functions. Name function pointers, maybe. Name functions. Let's go in there. So we do name functions. Named named okay, I think that is better. Yeah. And then we add a builds source lines okay, builds functions source lines. Name function. Yeah. And we need a PDB reader. PDB like this. Yeah. Okay. Then we put this here. Voids span. Okay, span. And then we say for this we do named function named data named we do pdb reader dot find function by name named name. Now the question is named, hold on, named function, name function, build name function, build name, get symbols. I'm not 100% sure if there should always be a found function. I'm not sure. Maybe there's not. Let's put a pdb function info what it's called, pdb function so I'm not sure if assert not null is valid. Let's put it there for now. Let's see. If pdb function is not null pointer, then we also need pdb reader get source files, source file info vector, pdb source file info vector, source files const source files named function dot set source file is source files pdb source file id if pdb function has valid source file ID, let's put it here, and source file ID pdb source file info const info source file and pdb function source lines. Okay, set source file, and source lines. There we go. Okay, that should do. That's simple enough. Okay, this is build function source line, build functions source lines, PDP reader. Yeah. Okay, I like this. This is nice. It's pretty much the pendant to this one. Can be used to build, to get source lines of a single function to build source lines of single function too. Okay. I wonder if we should also then add this function variance. Builds bundled functions source lines. And we say here can be used to build source lines of a complete bundle with two calls. And we give it named functions and named function indices. Yeah. And we give it a PDB reader. Okay. And this will be runner, name functions, data. So it will be similar to this here. Index named function indices. Named function. Tell me to named function, named index and this is to take this and then we take this PDB function named name PDB function let's put a question mark here. Is this appropriate? Is this assumption correct? Can probably simplify this further by build function source line void named function PDB reader. And there we take all this named function okay. Then we call this build function source lines and put this here. PDB reader. Static runner. Then we delete all this and this named. Okay, simple enough. Build function source lines. Okay, builds. Build function source. Maybe we can't make this assumption here. But we need to see it, because if we can't do it, then we should track that in this named function we at least have tried once. Or actually, hold on. There's another way. It's linked. No, there's no other way. We would have to add a boolean can link to source file true is linked to source file. Can link to source file. Then we say if this here else name function can link to source file false. So it cannot link. Oh shit. There we go. And then we should say here, this is fully linked to source file. We should say, oof, I need to get told of link to source. It should do another UN32T linked. Not linked or cannot count of files that have been disassembled in this bundle. Count of functions that have been disassembled. Count of functions that have been linked to source files in this bundle. Cannot link source file counts. Count of functions that cannot be linked to source files in this bundle. count of functions that have been matched functions that have been compared with each other. Have been compared with each other in this bundle. Cannot link source file count. Cannot link source file count. Is there a better name for this? Cannot link to source file. Can link to source file. We call it missing source file counts. And this we call linked source file count, update, linked source file count, okay, and then here we say, we put this here, and we say else if dot if not can link to source file, then plus plus missing source file count. Same here. Maybe we shouldn't. Let's not return anything. Void. Okay, and then here we say is linked to source file. No. Where is it? Why is this here? confused. It should be down here, no? So it's fully linked. So here we do this plus missing source file count equals get total function count. Yeah. It's fully linked. This is a bit ambiguous here. Is let's rename this to it's fully disassembled. Let's rename this to this link. Oops. Let's has completed comparison. Has completed comparison. Has completed source file link. Has completed source file linking. Source file linking. Has completed disassembling. Is that fair? I think then it's less ambiguous because now we don't make the claim that all source files are linked, but that the linking is completed, which I think is a bit better wording. Has completed comparison, has completed source file linking, has completed disassembling. Yeah, I think that is fair. Okay, and this way we know that this job is done, right? Okay, let's get back to runner. Build function source lines. So if for some reason we cannot find a function which should be happening, but let's assume it can. Can link to source file. Yeah. Well, let's put an assert here. I want to see if it hits or not. If it doesn't hit, then maybe we can remove this stuff again. Let's put not put. Is this necessary? Okay. Good. So we got to build function source lines, build I don't like the naming of these functions. It's confusing. Build function, named function. Okay, we should probably add a static void disassemble function, and we put a function and setup. Ta-ta. Runner. Okay, and in here we say if that, then that. Let's see, disassemble. Let's simplify this to disassemble this and setup. Named function setup. Disassemble function pair. Zero. Setup 0, 1, 1. Okay. Simplifying it. Good. Let's move this here. Okay, so we have disassemble functions, bundled functions, matched functions, and just a single function. Okay, so build function source lines. Build function source lines. Let's see. Build function name function. Build source lines for functions. Build source lines for bundled functions. Build function source lines, that's just one. Okay, but here we got some more. What about for matched functions? Yeah, how about we do it for matched functions as well? Build source lines for function. And then we add a build source lines for matched functions, where we pass named functions pair. But that doesn't make sense. That doesn't make sense. Or does it? What do we do in here? We should probably do it similar to this here. Yeah. So build source lines for matched functions. And there we pass PDB reader pair, const PDB reader pair, and this. And then we do this. And here we pass we take this here and we do matched functions to function pair, named this, match that, and then we do build source lines for function, and there we pass wait, what is this giving? Oh, it's just giving function. I think we need another function here. To named function pair. Using named function pair because we don't already have enough of these guys. Named function. There we go. Okay. And then we return this to named function pair. Named functions pair matched. And we return this, this. Right. Yeah, it looks pretty unreadable, so it's probably correct. Back to runner. Named function pair. Do a named pair. Named functions pair matched named pair. Then we do this named pair, named function. Yeah. Named pair 0 and PDB reader pair 0. We can probably do for size t I equals 0, I smaller this. It's not necessary. Actually, yeah, let's do that. pdb.size plus I if pdb reader I is not null pointer, then do that. Oh, hold on, that is highly inefficient. Let's do it here. Oof. 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 I just realized now that we should probably do it. Oh. Well, that's a little bit unsettling. How do we do it on the other? Disassemble bundled function. That's a matched function. Okay, here we assume that that these things are not null. Yeah. Right. So stands for matched functions. But here, one of the PDB reader is likely null pointer. I don't know. PDB. PDB reader pair. Yeah. Yeah, for const pdb reader pdb reader pair No, that's not right. For size t, I equals 0, I smaller, PDB reader pair dot size plus plus I. I okay. If PDB reader equals null pointer, then continue. Otherwise, let's do this and match functions. The only downside is now we need to go through matched functions twice, but since we expect that more likely than not there's only one PDB reader in this pair, I think that is okay. And then we do to named function pair. Then we do named functions pair 0. No, no, matched dot named index pair I dereference by way to add const named function named that, and then we do build that named and PDB reader that, and that doesn't work. Why not? Name function PDB reader named. Something is wrong. Name function. Because it's const. There we go. Okay, this will work. Yeah, I think that's fine. That should be fine. We can probably make it even a bit simpler here to this. Then we move this here and this there and boom. Okay. Okay, this also means we can go back here to this and remove this because we didn't actually need it. Remove that garbage. And also remove it here. Okay. And here I realized that we can actually use add, which makes it simpler to read. So let's do that. Add right? Da, da, da. Yeah. Da, da. And this stuff is still used, right? Hmm. Hmm. That's fair. Const function pair. This one. Okay, I think that's fair. Okay, is this already complicated enough, or can we make it more complicated? Build source lines for function. Okay. Now the question is, do we still need these two here? Maybe not. Maybe we can remove these. These are the legacy builds. Where is it? Here, this one, where we go through the sources and functions. But it looks like we don't need to do that. Source lines for function. What about this one? Okay, which are these here? Yeah, so my suspicion is that we don't need these two here. And instead we will just call build source lines for, what do we pass? For matched functions. Build source line for matched functions, and we pass this and matched functions. There we go. And this way we also only build the source files for the matched functions, which is the only thing we need for the for the ASM comparison here. Now I actually do we still use this? We do, but just for the bundles. Just for the bundles. It would be nice if we could get rid of this as well. But maybe that's not possible. The index map. Okay. Then I would say we delete this stuff here. Let's look at this once more. So we have build source lines for matched functions, for bundled functions, and just for functions, span. Yeah, I think this is enough flexibility. It should cover all the use cases we have for the UI. So I'm inclined to just delete this guy and remove all this here. Yeah. Okay, then the next question is Create a single bundle with all functions. Ah, hold on. There was one. Before we delete this, let me bring that back. Let me bring that back. Let's put here delete begin, delete end. As we were testing this, delete end. As we were testing this in a previous video, it hit a bunch of asserts. Maybe we should look into that. So let's try to get rid of those asserts. So we have this guy. Let's comment that out as well. And here we pass again. This? No? Function. This. Okay, let's see if we hit any asserts so far. I wonder. Yeah, I'm curious if we will hit. Oh, we don't go through that code yet. No, it's fine. Okay, let's see if it runs right now. Yeah, okay. Then let's go to to function CPP. And here we had a bunch of asserts hitting somewhere. Here, these guys. All of these. Okay, let's put them in there. And let's try to properly fix this. Let's remove the investigate comments. So one of these should hit now. Yeah. Good. So this is with E9, right? E9, yeah. Good. So we need to figure out where's this coming from? How do we prevent this garbage? Let's see. PDB reader. PDB reader. Can probably also remove this at some point. Good. I'm not really sure where to start looking. So, Okay, so the first question is, when we read, hold on, here, when we go in here, then we read here, read compile and function. Okay, so the first question I have is, do we actually get a E9 function, E9 thingy here? Let's put it here. If function, if function info dot function integrated name of $E9, right? $E9. What's the problem here? Stop debugging. So if that or dot global name, I'm not sure if all the checks make sense here at this place, or function dot undecorated name. Yeah, that should cover it, I guess. Let's do, just put a break here, I don't know, like this. Test. Okay, let's see if we hit that or not. We do. It is global name, static void, E9. Okay. Shit. So length is 22, and this is also 22. So that actually matches. Yeah. Do we hit it again? Yes, we do. Okay. That's interesting. Kind of. Length 5. Length 5. Source line 0. Huh. We have another. That's wild. 5, 0. Okay, but what was the problem now? The problem is that begin address. So this one has size 5, like what we have seen in a later one. And no instructions. No instructions. Maybe. Function. Okay. Okay, so I see one problem, but that doesn't explain everything yet. Source lines. Yeah. Okay, so the problem here probably is that since we have multiple E9s, we have an ambiguous lookup by name. So we probably need to look up by address. So named function to index map is not the proper thing to do. So what we should do in the PDB reader, we should look up by address. And so then when we go to here, named function, then we look up by address. Find function by address we should do. Yeah, named function. Okay, let's go to here. Find function by address. Then we do address 64. Address 64T address. And then we do we rename this to function address to index map, and then build function address to index map, find function by address, find function by address, find address, function address, address index, okay, and here we do function, let's do function dot address dot apps virtual. Move this and done. Done. Okay, we're making real progress here, I would say. That's good. Address to index map. Okay, good. And this should give us more accurate results, since we do have, since we can have functions with duplicate names. Which is bad for comparison. Yeah. Okay, let's go to runner, yeah. So we say find function by address, address, name function dot begin address, done. There we go. Okay. Maybe we do address, this address. Okay. Okay, this should get rid of some asserts, but there might still be others left, but we can revisit this another time when we look at E9 again. Okay, but this should now work, and we shouldn't hit any asserts anymore, I think. Let's see. Yeah. Oh, we do hit assert. Okay, let's see what that is. Ah, we hit this. Okay. Address. What is this? Name function exception. Okay. Okay, so there will be some functions that have no source files, like this exception thing. Okay, that's fair. Then we remove this, and we are good. All right. Okay, that runs for now. What we can also do is we can test here with build source lines for functions, and we make a span. Name functions, name functions. Let's do for name functions. Let's do comment tests and tests named then we do std vector named function pointer named ptr resize named dot size, and for named name functions named functions named auto named ptr. That doesn't work. Size t I 0 smaller named functions size plus I ta 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 named ptr I equals named and build source lines for functions span. How do we create a span? How do we open the span? Oh, we can't see it. Why not? Here. How do we create a span? C++ create span. Span. Okay. Let's see. Is it that simple? It's never that simple. C++ never simple. Span named ptr. I told you, it's never that simple. Size t pdb I 0 pdb I 0 plus plus pdb reader pair I Yeah, how does this work then? I guess you have to do data named ptr size like this. No? Span. Create span from vector. There must be some simple example. No, no one wants to give examples. God damn it. Okay, that's a wrong way around. C++ vector to span. Come on. Why is no one able to give a simple example? Are you guys retarded? Are you guys retarded? Yeah, I see this, but vector. So somehow it claims it can be done like this. Okay, maybe I need to specify this. Oh, you have to be pedantic. Okay, I see. All right, well, fair enough. What's the problem here? Okay, this better hit now. Oh boy, there's still the compile. Yeah. I just want to test. Okay, so we have this, yeah. And we got a assert. Okay, cool. All right, we have instructions empty. Okay, what is it hitting on? Kind of. Ah, okay, that's the other E9. I see. Must be the other E9. No, it's init kind of mass. Oof. Okay. What's the problem then? Instructions is 0. But the source lines are 15. How can this be? How can this be? Huh? Okay, that is strange. There are certainly plenty lines here. Right. I see why this is 0, because we didn't disassemble it. That's why. Then let's go here. And let's do disassemble, named, wait, disassemble, bundled functions, disassemble functions. And there we also give the span and executable pair and format. O.format. Okay, that should work then, maybe. Let's see. Okay. Eventually we'll get through there without asserts. Yeah. Yeah, that's looking promising. Oh, we got some crash. Oof. Whoa. How is this corrupted? What? How did that happen? Memory usage looks okay. What? Okay, I hope this is just a debug bug. It's probably calling it on null. Oh, I see. Okay. How's this happening? Oh, because we never check. Right. Let's do if null pointer, then continue. There we go. That's fair. Okay, let's try this again. Oh, hold on. That is Okay, let's see. Okay, that passed without asserts, so I think we are in good shape. Yeah, maybe. Okay, let's remove the test code. That gave us a little bit of confidence, I would say. Good, then we can also delete this degenerate code. Did we delete too much? No. Good, and delete this here. Yeah, okay. And things not looking too bad, I would say. Yeah, we have a nice collection of build functions now here for source lines and for the disassembling. I think these give us all we need for the UI. Okay, now the last one, I think the last one, build comparison record. This one is also good. Um, mm, here we also need another variant for the bundles. So build comparison records. This is for matched build comparison records. Build. So we probably need a bundled comparison records. Bundled. Yeah. Bundled. Yeah. So we take this. Let me see. And we give it matched function indices, matched functions. Matched functions. We also need to give it named functions. Yeah, matched functions, named functions. Let me see. Named functions, matched functions, named functions pair, and matched function indices. Yeah, and we look at limits. This is log right. Matched functions, named functions pair, named functions. Build bundled comparison records. Can we use to this? Okay, there's actually another thing that just comes to mind, and that is here. Here we need to say, hold on. So on disassembly here, get instruction function dot, hello? Oh. It would be nice to use this okay. I'm inclined here to also use named function here. Like this, named function, named, so that we can say name dot is disassembled. Name dot function disassemble. Maybe that would be the better way. Disassemble function. Since we pass named function everywhere anyway, might as well be consistent here. Then here we need to make a change. Using named function pair, named function, and const named function pair, const, and then here we do const named let's rename this to pair, to const pair, make it unreadable, yeah, to pair. Okay. To pair, named function pair, named pair. Okay. That's named. Okay. And here to const pair, const name function pair, run comparison. Hold on. Here we need to. Okay, we do need a const function pair. Okay. Okay, back to this. Let's rename that to const named function pair. Const named function pair. And then we do a, let's put this down here. Then we do a const function pair const function const name const function const adds the function there we go. Okay. Okay, good. Now, do we still need this here? That's a question. No, if we don't need it, delete it. Good. Const. Okay, I hope that is complicated enough. Runner. Okay. Let's then go to build source line for function. So we should probably so if not is disassembled, and here we say maybe make an early return. If this return, otherwise disassemble. And here we do for function if named function name function dot if is linked to build source line. If is linked to source file is linked to source file or not can link to source file, then return. There we go. Okay, good. Anything else? Right. The comparison records. So here, match functions. So here we need to say, by the way, before we continue here, let me look once more is disassembled, is linked. So, okay, we have both these checked there. So matched function. Here we should say if matched function is compared, then we are also done. Yeah. Yeah. Matched. Functions. Yeah. I mean, it's a bit of a waste that we first do the function call to just return, but I think for simplicity, it's the best way. Yeah. Good. How about we also simplify this name here to matched. Matched. Okay, named. Matched function named function. Let's rename that. Named. Okay, what else? Compared, yeah. Okay, so next thing is this function here. Build comparison, right? Build, so we have, yeah. I think this is the last one. Static runner build bundled comparison records. So we have matched functions. We give named functions pair and matched function indices. Yeah, I think that is correct. And then what do? We do basically we do for index t index matched function indices, and there we do matched functions index and matched name function matched. Oh, yeah, okay. So we just pass on matched index. That's it. Well, that's simple enough. Okay, that's cool. I like it. I think our functions are not bad. I think this is not bad. I think it's actually really good. For the comparison records, for the building the source lines and for disassembling, we have now a couple options to build them by the matched ones, by the bundled ones, by this one. Yeah. 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 Matched functions. Yeah, I think that is pretty good. What we could also do, instead of passing vectors here, we could pass spans of indices. Would that be fair? Yeah, I think so. Pass a span. Yeah. So we have 1, 2, 3. Yeah. Named. 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 Build unmatched functions. Yeah. Yeah. Let's pass a span. Span index t. Yeah. Actually, hold on. No, that. Uh, I'm not sure right now. A span of index t. Huh. Hold on. Let me take a look at the span here. Make span. I think I think I did some mistake here with how I envisioned span to be used. Yeah. I think this should be a span of named function like this, not a pointer. It should be like this, right? Which makes it even simpler. Yeah, let's see. Name function, name functions, named, named. Yeah, I think it should be like this. Well, yeah, 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 I think that is fine. So you can give it one element or like a range from the original named functions vector. Yeah. Yeah. So you can't build a range that is not within the original contiguous memory, but you can take chunks of it or a single element, which is fair. I think that is enough. Yeah. Otherwise, you would first have to build, if it was a span named function pointer, you would first have to build a std vector of pointers, but it's unnecessary work. We don't do this. We only do efficient work here. Yeah. No useless things. I think this is good. This is very good. Yeah. Okay, and then what we do here with this we do span index. Span here. Hold on, there needs to be a copy. Span here. Span index and here span. Okay, then we check this guy. Span. There we go. And that works just fine. And here span that. All right, and here as well. Span. Yeah, I have never really used span before because I haven't been using C++20 yet. But yeah, I always saw it and I always thought it makes sense. Have a generic range instead of passing a vector. Because then you could theoretically also pass a std array, right? So, yeah. Okay, cool. It compiles. Oops. It compiles. Great. I think I'm very happy with the progress, even though it doesn't look like much. But this was hard to do. This was really hard to do. But I think what these functions allow us to do is really efficient building. So like in the UI, we can pick and choose certain aspects to build. Like we don't have to build the whole thing as we browse through the file and look at comparisons, but we just can click certain things and it will just selectively then build things provided by this functionality. So we can call it for a single function or a range of functions. So it should be fairly fast for our use case, even with just a single thread. Yeah. So Right now, everything is, all the work is on single threads in the work queue. Now, obviously, that can be improved as well later on as well to make it extra fast. But I think the first optimization is always to reduce the work, the overall work. That is always the first optimization. Before you think about multi-threading and like more complex algorithms, which go like into details, you first try to reduce the work. That's the most important. Don't do more than you need to do, right? So if the UI doesn't display all the stuff at once, then you don't process and calculate all the stuff at once, right? You just do it on demand, right? Yeah, that's I think that's always the best way. Yeah, and then of course it still will be slow in the end, right? And then you can do more sophisticated optimizations with multi-threading and stuff like this. Yeah. Maybe there are also more optimization potential here and there. But I think it's fine. Yeah. Okay, good. Then next step. Does it compile? Yeah, it does. Good. Now we still did not improve the build match bundles function. That is still a little bit dirty, I would say. Can we improve this? Named functions. What's the time? Oh, I think it's time for ending this. Yeah. Okay, well, 2 sessions ago I said we look at this, but now we did a whole bunch of other things. Well, it's okay. We did good progress. And then let's look at this in the next session again, eventually, maybe. Yeah. Name functions. The match bundles are quite complex matter. Actually, this is the only function now that takes this this index map. So if we would be able to get rid of this here, this here, if we could get rid of this, that would also be great. But can we do that? What is it used for? It's used for here, function name. Well. Well, what if we always also do the inverse here? Instead of using this index map, we look up we look up the PDB function info with the address from the PDB reader, right? Yeah. Yeah. That way we could get rid of this this here. Then we don't need this anymore. Okay. And then, yeah, but then we also don't need this here. Yeah. Okay. Yeah. And then we can also build match bundles. Build match bundles. Okay, let's try to implement that. I think that's maybe a good idea. Yeah, it might make things simpler. Yeah. And then maybe we can also break it into chunks. I don't know if that makes sense. No, it probably does not. No, we want to build the bundle in one go. Yeah. Yeah, yeah. Yeah. Okay, but let's try to get rid of this first. I think we can do it. Requires a little bit of refactoring here, but it should be possible. Okay, how about we run this now once to see if it actually still outputs results. Let's see. Run this. Yeah. Looks looks normal, I would say. Yeah. 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 Good. I think that was a good session. 2 good sessions, actually. I'm very happy with the progress. It was quite a lot of work the last days. I think yesterday I was actually quite a bit frustrated, but it turned out okay. Yeah. Good. Then, yeah, I will take a break now and wish you a great day or night. Until next time, goodbye.